Hi folks, finally got a chance to do a couple more videos, and what I want to talk about today is something I got hold of sometime early summer last year. And at that time I was doing an IPv6 deployment project here in Frankfurt that has been running for about 20 months altogether. I was also doing a couple trainings for various customers on IPv6 as usual. And one customer I've been doing 5 or 6 trainings with was a company called Spirit 21 with locations here in Rüsselsheim near Frankfurt, in Böblingen near Stuttgart, and in Zurich in Switzerland. And during the first training, I think it was, we came back from lunch break and I found a couple things on my desk, including coffee mug, or in my case tea mug, one of those habits I picked up in Australia a long time ago. And so this is Spirit 21, this crowd. And it wasn't just the coffee mug as a pretty much standard giveaway. They also had something else for me, and that was a real surprise. Now, they had heard or found out that I've written a book on IPv6, and it was covering all sorts of Unixes, and what they got me was this. An original, almost mint condition SunRay 1 ultra thin client, developed, produced and sold by the late Sun Microsystems, now victim of Oracle. And these things were revolutionary in their time. They first came out in '98, so this stuff's about 18 years old, or if you just think about the design phase, roughly 20-year-old. And they really caused a commotion at trade shows and wherever people first saw them. Despite that, they never got all that popular. They always stayed a niche solution, which is kind of interesting aside from the more historical aspects of these. Now, first off, this is what they call design. Basically means back in those days when everybody and their dog had a big tower under their desk, or if you were unlucky you had a desktop machine which would take up hideous lots of space on your desk, usually in this beige, eventually turning hepatitis yellow color, and but ugly, noisy and whatever. And Sun came up with these sleek little things. Well, small by those days standards. Compare those to a Raspberry Pi today. Okay, they lose, but hey, this is almost 20 years ago, right? And why did these things cause so much of a commotion? Well, let's first take a look at the hardware. Now, what's really design and artsy and whatever, the actual thin client doesn't clip into the base or anything like that. It's just sitting in there loosely, which is kind of annoying, weird, whatever. But well, that's the way it is. And oh, by the way, you couldn't just, you know, take a bit of hot snot or whatever and stick it in there, because then you'd have a hard time getting to the various connectors inside because of this shape. Well, but let's take a look at the hardware. There's a power LED. Well, I guess it's an LED. Been an LED 20 years ago. What's missing, and that's a bit of a shame, is a power switch. Because that would be possible. This thing has a built-in power supply, so no power brick or wall wart or whatever. It's got a built-in power supply, and if they had just added a power switch here, that would have made it kind of easier to save a bit of power, basically. Next thing we have, oh, hang on. What we don't have here is a fan. We've got a metal case. This isn't plastic, this is actually metal. It's dissipating enough heat without a fan, so that's nice. Power consumption, according to my ultra high-end measurement tool, picked this up for about 10 euros or so at a Home Depot. It's about 15 watts, which again doesn't compare all that favorably to today's Raspberry Pi or anything, which according to that same device doesn't draw any power at all, because that thing only starts showing anything at 10 watts up, and Raspberry Pi doesn't draw more than 2.5 watts if I remember correctly. But for those day standards, that was pretty good. Okay, what else do we have? A smart card reader, and I have a smart card. Now, this will get interesting later on, but for now we just leave it at that. Audio out, audio in, or the other way around. Yeah, now audio out, audio in. So that's different from what you find a lot of cases with thin clients based on RDP, or at that time X11 or whatever. You could actually forward audio to the server through this thing. Back we have, well, the power connector. We have 100 megabit fast Ethernet, and 98, that was a time when fast Ethernet was still fast. Basically you'd have 100 megabits on servers between network components, but rarely to desktop machines. It was just about starting to become economically feasible to have 100 megabits, but most network wirings were, well, it was a matter of luck if 100 megabits would work across whatever you found in a building. There are 4 USB ports, and that's USB 1.1, but that's 98 stuff, right? Why 4? Normally for a thin client you'd need a keyboard and a mouse. That would be 2, not 4. But again, the interesting thing about this thin client system, this entire system, including the clients and the servers, was that you could forward the USB port to the server and actually use it, which was quite exciting in a lot of ways, but also made these things harder to sell. We'll get about to that hopefully in another second episode, because that's quite a topic by itself. We have Vga Out, and these things at that time did a whopping 1280 x 1024 resolution, where most of the people were still using CRTs doing 1024 x 768 only. So they were high resolution by those days standards. No, it's nowhere near 4K or 5K display these days, but then that was pretty good. And by the way, later models quickly had gigabit Ethernet, when very few desktop machines had that at that time, and DVI doing 1920 x 1200. There's, and that's really weird again, there's a video in, composite video in, so you could hook up a video camera in there. And no, that was not for Skype, because Skype wasn't there at that time. That was because people used these things, for example, in hospitals, where they actually used cameras or camera-like devices to take all sorts of pictures of things. There's audio in and out again. And then there's this pre-Kensington lock security device, basically a little aluminium block with a screw inside that keeps the case closed. So if you ran a padlock through these holes here, you couldn't access the screw, couldn't open the thing up, and you could actually lock that thing to some bit of chain to your desk or whatever. Sun has been using things like this for as long as I can remember. So that's the hardware. What's missing? Well, a fan, obviously. I mentioned that already. There's no hard disk, there's no floppy drive, there's no CD-ROM. You could hook up things externally through the USB ports if you had the time to do anything like that over USB 1.1 and a 100 megabit Ethernet, but they didn't have any of that built in. So, nice, sleek, small footprint kind of hardware, really designy. But the interesting thing about this is really what happens when you actually hook it up and connect it to a server. And I'm going to do that in a moment. However, the interesting thing about these during that training was that later on, the same day they got me this, I talked about microsegmentation with IPv6. Now these things don't do IPv6, at least not to my knowledge, but there was a later model of these which had 1920 times 1200 video display, which was why I got interested in it, had gigabit Ethernet, and which also had a gigabit Ethernet fiber connector, 1000 base FX if I remember correctly. And there was a white paper from Sun which suggested that in high security environments you'd use fiber because it's harder to tap rather than a copper link, and you'd also put every single thin client into its own subnet, doing basically the same thing I've shown in episode 13 if I remember correctly, on how I added additional network interfaces to a notebook computer using tagged VLANs and so on. And they also suggested that for high security environments with these thin clients. And what does it have to do with IPv6? Well, basically nothing, except that in rather special circumstances you might actually opt for connecting every single device to its own subnet. With IPv6 that's much more feasible than with IPv4, but even with IPv4, with these, Sun already recommended that for certain, in that case, security critical situations. Okay, now the craziest thing is, when I mentioned that in the training, immediate reaction of course was, Benedict, you didn't just bring that up because we gave you this puppy. No, that's what I tell people pretty much all the time, but now I have a SunRay to tell and show and explain to people. And next thing that happened, second training I was doing there, I arrived, and pretty much the first thing I've heard, Benedict, by the way, we found the other one. And believe it or not, I have a second one already hooked up here, which is really nice because it lets me show you something that's really, really, really cool. So let me get this hooked up, and then I'm going to show you why these things were so exciting to a lot of people. Hang on. Okay, got these set up. They're all hooked up. Monitors are on. By the way, sorry, but I don't have any of those old original Sun monitors with the Trinitron tubes and things, which were nice back in those days. Don't have proper Sun keyboards, proper Sun mice, but it works. Okay, first thing to do is take a bit of ultra high-end measurement tool for the time domain, basically a 3 euro stopwatch, and see how long they take to power up, right? And here we go. Yep, that's an Oracle logo. Can't help it. Late Sun Microsystems is no longer. It's all Oracle now, which is decidedly bad news. And well, there we are. And it's, I hope you can see that, less than 20 seconds for these to boot. Now, important thing again is to think back 20 years, where a standard PC would start up, run this memory test, which took ages, then boot into Windows and whatever, take about 3 minutes to boot. So these are 20 seconds. So these are about an order of magnitude faster to power up, which is another reason why it's a shame they don't have a power button. And yet another reason why it's a shame is because, well, my other ultra high-end measurement tool, this one, energy meter, cheap one I picked up at the Home Depot, says they need about 15 watts, which is decidedly much compared to, for example, a Raspberry Pi. Raspberry Pi draws at most 2.5 watts, and according to that thing, doesn't draw any power at all, because this measurement thing claims it only starts to display anything from 10 watts up. And what we have at this point is basically a better X-term. An X-term with the additional capability of hooking up a speaker, a microphone, a camera, or whatever else you want to hook up to the USB ports. And you could still use that on the server. There is a Linux version of the software, but it doesn't do all the stuff with the hardware. So it's more limited because integrating that into the software is kind of tricky. And Sun did that for Solaris, where they had full control and people could actually say, we want this in. But doing this for Linux, where there'd be also discussions like, well, yeah, but we don't want this in our kernel and so on, that was pretty much hopeless. So the Linux version was eventually released, but it doesn't do all the features. And what we have here, better externals. Let me log in and then I'm going to show you what these smart cards are interesting for. So there's, oops. Now, here we go. I've set up some slightly different desktop backgrounds, so I can show you a couple things later on. At this point, we can start applications. Let's see, games. Games is always good for this. There's one game, whatever that is. Games. And oh, they look pretty similar. Sorry, let's just move them someplace so you can see there's a difference. That's basically a better extern. But when the smart cards enter the game, there's something we can do. Put a smart card in here, and there's a login prompt. Now we can log in again. And now we log in as yet another user and start yet another game. What do we take? Tetravex. That's easy to recognize. That kind of makes sense. I can even rescale that. Whoa. So we can actually insert our smart card, and without really disrupting, just suspending the original session, we can actually use this, which is quite nice. So basically, well, you can pull out the smart card, put it back in, and there's your session. This is nice. You have to do a couple tricks for this to work like this. You have to tell the server, don't ask for password every time somebody attaches a session or reattaches or whatever. And you have to disable the screensaver on there as well. But I mean, this is nice. So just put in the smart card and there's your session, which is cool. Which is already cool because it's like, excuse me, may I use your terminal for a moment? Just a couple seconds, and smart card in, do your job, pull it out, and not having people to log out, or exit their applications, whatever. That was already quite nice. But the real fun thing is, I mean, no, I don't like this to be all that big. The real fun thing is, if you take out the smart card and put it back in a different thin client, because the session is associated with the smart card. You could actually move around between terminals in your organization, building, or whatever, and take your session with you. And that really caused a commotion. I mean, these days you just give people a tablet or something like that, but back in those days, smartphones were non-existent. Dumb cell phones were for executives only, well, kind of. And the only thing anywhere near a smartphone or tablet or anything were these horrible Palm Pilots, which were just a huge waste of time and money, at least in my opinion. This really got people excited. Just the mere idea that they could continue working wherever they were in a building was absolutely unheard of. And I've been told that this got pretty popular in hospitals, for example, where there are all sorts of people running all over the place for all sorts of things, and they just take the smart card with them, you know, like and put in a shirt pocket I don't have, and then go elsewhere and continue their work, or gaming in this game. So that was really, really, really exciting. Question is, why did this stay a niche solution? I mean, people who have ever worked with this and were eventually forced to go back to some standard PCs or whatever, they really missed this feature. I've had a lot of people, not a lot of people, but I've run into a number of people who've been working with these and their successors and really missed this capability once they had to return to regular PCs. Yet it was always a niche solution. So much of a niche solution that Oracle, in their infinite wisdom, decided to discontinue this. Why was that? Number of reasons, and there are a number of reasons that have to do with the specific features of these. There are a number of reasons that were applicable to thin clients in general, and I'll do another episode on that next. But what really caused me some pain for starters, and which is enough to tell about, is the server side. This one, running in that virtual machine. I mean, I've got these babies, I think it was June or so last year, maybe May, it was early summer. And it took me until 2 weeks ago to get this up and running. Just to give you an idea what happened. And I probably missed some of the problems I've run into, but what happened was you need the server software. Okay, so you go to the Sun website, which doesn't exist anymore, but redirects you to Oracle. You look around, and after a couple of tries, I actually found that stuff. Didn't find it right away, no chance. It's discontinued, so we put it somewhere where nobody's going to find it anyway. Got to a download page for the software, and you needed a login. Basically, you give us your email address and we will give you some chance to look at things for testing and evaluation purposes only, of course, which is what I'm doing here. And I found the software, downloaded it, and then I needed Solaris to run it on. Obvious choice, open Solaris. Avoid these stupid license things if you can. Open Solaris is free to use, why not go for it? Installed Open Solaris in a virtual machine on that VMware server, notebook thing. Didn't work. Software didn't even remotely try to install. Good. So another Solaris copy I had lying around was Solaris 10 Update 6, which was the last Solaris version I seriously used or dealt with. Installed that in another virtual machine. Okay, install the software package. Okay, read the associated documentation coming with it. You need a Java runtime version 1.6 instead of 1.5 shipped with update 6. You find a tarball here to install. No, not a package, a tarball. And some explanation how to install it. So you extract the tarball, put it where you might expect it, tweak some symlinks, and hope that the new Java version doesn't break anything in update 6 outside this server. Good. You also need a new version of Tomcat, also included, not as a package, but as another tarball with the server software. Okay, install that. Same procedure. Except for a service to start, you need a service manifest for the SMF service management framework, which is the Solaris equivalent of Upstart or Systemd or anything like that. These are XML files and they are a huge pain in the ass to write. And I eventually found one on the not Oracle website. No. found one at the Apache Tomcat website. One that didn't work, but which I could actually make work, messing around with Java environment variables and paths and whatnot. But I got it up and running. And at that point, I could actually check out the server software. There is a management front end, web-based, using that Apache Java, blah, blah, blah. And yes, I could connect to it, log in, and see that there's a server running. Not just the front end, but also the back end. Cool. Hooked up, thin clients, powered them up. Didn't work. Okay. Well, maybe use another Solaris version. Went back to the Oracle website, and thankfully they let me have a copy of Solaris 10 update 13 with this user login rather than expecting another service contract, and downloaded that, installed it in a virtual machine, installed the software. Didn't have to do anything about Java and Tomcat or whatever, because update 13 came with a later version of those already. But the software didn't work. The server simply didn't, the management front end didn't show me the server as a backend machine. At that point, I gave up for a number of weeks. Eventually, I found myself searching the web again, learned that there is an open source re-implementation of the server side in Java, so it might even run on FreeBSD, or at least Linux, but it only supports SunRay 2s. Not SunRay 1, not SunRay 3. Bummer. And then at some point, just out of curiosity and stubbornness, or whatever you want to call it, I decided, let's see exactly where things get stuck. Started Wireshark, started the server VM again, started the thin clients, and looked what was happening. Turned out that there was a DHCP handshake going on, and afterwards the thin clients just stopped. And I had this hunch that the problem was due to DHCP vendor-specific options, which might be used to communicate something to the thin clients there. Good. Which ones? Went back to the installation manual. By the way, there's an installation manual and there's an administration manual. Went back to the installation manual, checked everything, was pretty sure I'd done everything right. Okay, give it one more try, scrap that virtual machine, do it all over again. Good. Same problem. They'd get an IP address through DHCP and then stop. Okay. Check the installation documentation once again about DHCP, but didn't say anything about it, so I just set up a address range for DHCP. And eventually, just out of curiosity, if there were any vendor-specific options involved that were not listed in the installation manual, I checked the administration manual. And there I found something that said, yeah, blah, blah, you have so, so, and so, and so to configure the DHCP server for this to work. Now, the DHCP server with Solaris is special, to put it politely. It's hiding all sorts of stuff in whatever databases or whatever. It has command line interface, but there's no configuration files or lease files where you can actually look into. And well, I ran that command, fired up thin clients, and after 9 months of hard labor, these babies actually came to life, sort of. Whoa. Anyway, that is one of the reasons why these SunRays were never particularly widespread. People who have been using them were usually quite happy with them, despite the fact, and there's another problem, I'll show you. If you pull out the smart card, put it back in, you see it takes a bit of time for the screen to recreate. As soon as you do anything that's doing lots of graphics, 100 megabits is slow. That's one of the problems here. But even then, people have been using them in hospitals, but not in a general practitioner's office, for example, like my old man used to be. And why is that? With the trouble I had to get this up and running, you need pretty much a full-time Solaris administrator to take care of this, and one who's working with this on a regular basis. Otherwise, I mean, if I had to set this up under time pressure, it would have taken me 2, 3, 4 days, and nowhere in that time I would have known, okay, I'm near there, it should be done in a couple hours or so. It was just, I didn't know if I could get it to work at all. And that's not something you want to do. In a larger organization, you can have somebody doing this full time, but for a small office, not much of a chance. And these IT operations, contractor support people who take care of small, medium businesses, who have to take care of everything having to do with IT, like, well, you know, cleaning the telephones, refilling toner in a printer and that sort of stuff, and doing the security stuff on the access routers, and they don't have a chance with that. They never had. So that's one of the reasons why this never got that popular. Now, that was as much as I wanted to show you for today. I mean, especially, I still love this. This is just fantastic. But what I want to talk about in the next episode, and I hope I'll get a chance to record that real soon now, is why thin clients were never that popular and are ever more historic by today's standards. Because thin clients solved a number of problems back then, but we've got better ways to solve these problems. A lot of things have changed since, and they actually introduce a number of rather nasty other problems and expenses, if you want. That's stuff for another episode. So far, I think I call it a day. It's been a long one. I mean, I've been busy doing nothing all day, just getting out of that project. I really deserved that. I hope you like this. There will be more about this real soon. And if you want to discuss or whatever, come over to the BIVBlog forum, which is here. And hopefully see you again soon. Bye.